To the video lecture on the course of AMP and Linear Integrated Circuit. In this session, we will be discussing the topic of DC voltage regulator, and especially we will be concentrating on adjustable IC regulator. In the previous session, we have seen a positive adjustable IC regulator which was LM317, and in this session, we will be discussing a negative adjustable IC regulator which is LM337. The LM337 regulator IC is a counterpart of LM317, which is having a output voltage range from minus 1.2 volts to minus 47 volts. The LM337 is widely used negative voltage regulator IC, which can be used as an adjustable voltage regulator. Both line and load regulations are excellent compared to standard fixed voltage regulator ICs. The various protections such as thermal protection, overload protection, short circuit protection, current limit protection is internally provided in this LM337 voltage regulator. Now seeing the connection diagram of this LM337, it is similar to that of LM317, but with a slight modification with the pin numbers so that we get a negative output voltage. Seeing this particular part, in this case now for LM337, the adjustment pin is the pin number 1, the output pin is pin number 3, and input pin is pin number 2. So in this case now, so this will be the LM337 IC regulator. Here, as we can see from the circuit diagram, the direction of currents are opposite to that of LM317. The current is moving into the IC, which indicates that we get a negative value of output voltage. Internally, this IC develops a reference voltage of minus 1.25 between the output terminal and the adjustment terminal. The current I adjustment flows into the adjustment terminal, and along with IR1 flow through the resistance IR2. So the current through the resistance R2 is nothing but the adjustment current and the IR1. The maximum value of I adjustment is 100 microampere, which is very small, and for our theoretical cases we neglect that particular value of current. Seeing this particular diagram here in this case now, so this is accordingly what we have just modified it so that it gives a clear indication how the current is going to flow in this part. The capacitor C in is required if the input if the regulator is located more than 4 inches from the power supply, then the filter capacitor C in is required. Similarly, a capacitor C naught is required on the output side for stability part. Similar to LM317, the expression for output voltage V naught will be equal to minus 1.25 times R1 plus R2 divided by R1 minus the adjustment current into R2. Since the adjustment current is very small and hence the drop I adjustment into R2 is also very small, it can be neglected. So we can write V naught will be equal to minus 1.25 1 plus R2 divided by R1. So with this part we get the negative output voltage, which can be varied by using a resistance R2 if we use a variable resistor. So thank you for watching this.